Welcome to Homework Lib.
Okay, so here there are two parallel slits that are separated by a distance d equal to 0.0116 millimeters, right? And they are illuminated by a laser beam of wavelength lambda equals to 585 nanometers. All right. So if you want to convert these things into SI, this will be 1.16 into 10 to the power minus 5 meter, and this turns out to be 5.85 into 10 to the power minus 7 meters. All right. So now what we have to do is to find the total number of bright fringes that can be seen at a very large distant screen. So for the bright fringes to occur, we can have this relation d sine theta will be equal to n lambda, and where n is the number of fringes, nth fringe, right? So and the theta is the angle made angle between the lines that is drawn from the center of the slit to the center of the fringes, and the line from center of the slit to the point at which we want the point where nth fringe occurs, right? So to find n, we can say n equal to d sine theta by lambda. So what is the maximum value of n? So if we want n to be maximum, then we want sine theta to be 1. So n max is equal to d by lambda, right? So what is d by lambda now? So just divide these quantities, 1.16 into 10 to the power minus 5 upon 5.85 into 10 to the power minus 7. So this gives me n max is equal to 19.8. So in numbers, since the fringes should be counted, we cannot say point something, so this means there are 19 fringes that can be seen. Now we have to be very careful that this is the number of fringes that are above the bright central fringe. So if we want the total number of fringes, so n total is equal to 19 above the central bright fringe plus 1 the central bright fringe plus 19 that are below the central bright fringe. So altogether we will have 39 bright fringes in the screen. Okay, so the next question is asking, so we are done with part A of the question, right? Now part B of the question asks us to calculate the angle that is made by the most distant fringe. So the most distant fringe, for the most distant fringe, n is equal to 19 because there is the 19th fringe, right? So let me write that plus minus 19 because we will have the distant fringe on both sides. So sine theta equals to n lambda by d, right? So what is n? Plus minus 19. Now lambda is 5.85 into 10 to the power minus 7 meters upon, this is d, okay, small d. So small d is 1.16 into 10 to the power minus 5. So this gives me sine theta is equal to plus minus 0.958. So just into sine inverse of 0.958 gives me theta equal to plus minus 73.37 degrees. So the 19th fringes are at an angle of 73.37, and hence this ends the solution for this question. Thank you for watching.